Today's lesson is on applications of quadratic equations. First, let's talk about some strategies for solving any application problem. You want to ask yourself some questions before you begin. Could you draw a picture to identify what's happening in the problem? Can you identify what you are being asked to solve for? Can you write an equation? If so, should it be a linear or a quadratic equation? We're going to answer all of these questions in this video today. Let's start with an example. One side of a rectangle is 4 inches shorter than 3 times the other side. Find the length and width of the rectangle if the area is 319 inches squared. So let's start with, can we draw a picture of what's happening in the problem? I think in this case we can, because we're talking about a rectangle. It doesn't have to be a very neat rectangle, obviously. It says one side of a rectangle is 4 inches shorter than 3 times the other side. So it says one side of a rectangle is, well, let's call that the length. So we're talking about the length. Is means equals. 4 inches shorter than means we're going to do some stuff minus 4. Well, the stuff is 3 times the other side. Well, the other side is the width, so that's W. One side of a rectangle, the length, is 4 inches shorter than 3 times the other side, and there's the width. Now it says we're going to find the length and width of the rectangle if the area is 319 inches squared. That doesn't mean that we square 319. It means the units are in square inches. Each one of these units is a square inch. There's 319 of these little squares within this rectangle is what that means. All right, so we've drawn a picture. Now the question we should ask ourselves is, what are we trying to find? Well, remember, we're trying to find both the length and the width, which conveniently I already have in my picture and I'm about to put into my equation. So the question asks, can I write an equation and is it a linear or a quadratic equation? Well, if I was adding all of these for perimeter, that would be linear. We've done those before. But instead, I'm finding the area. Remember, area of a rectangle is length times the width. Well, I don't know the length times the width, but I do know that the length is 3w minus 4. And so that has the advantage of giving me one variable, w, instead of two variables, L and w. It also gave me the area, which is 319. It's unnecessary to put my units in the problem. Well, let's think about whether this is linear or quadratic. When I distribute my w, 3w times w is 3w squared. Negative 4 times w is negative 4w, and that equals 319. This is a quadratic equation because I have the w squared and the w. It's not linear. If it was linear, I would just have one of the w's. That means I'm going to have to solve this using either factoring or the quadratic formula. In either case, I solve this by getting this equal to 0 so that it's in standard form. So I'm going to subtract 319 from each side. That gives me 3w squared minus 4w minus 319 equals 0. I'm not trying to factor with the number 319. That's going to be too hard for me to find factors. So instead, I'm going to use the quadratic formula. Remember, you don't have to have the quadratic formula memorized, but you do need to be able to locate it in your notes and you need to be able to use it. Quadratic formula is negative b plus or minus the square root of b squared plus negative 4ac all over 2 times a. Remember, we don't put the variables on our a, b, and c. A is not 3w squared. A is 3, b is negative 4, and c is negative 319. So when I substitute in, a negative negative 4 becomes a positive 4 because there's a negative in front of the b and a negative on the 4. Plus or minus the square root. Well, b squared, a negative times a negative becomes a positive 16. Plus negative 4 times a times c. All over 2 times a. I'm going to go down here to finish this. This becomes 4 plus or minus the square root of 16. Negative 4 times 3 times negative 319. I don't know what that is off the top of my head, so negative 4 times 3 times negative 319 becomes positive 3,828, all divided by 6. Again, I'm going to finish simplifying inside the radical, so that's 4 plus or minus the square root 3,828 plus 16 becomes 3,844, still divided by 6. Now I'm going to simplify using my square root, so I hit my square root button, and then 3,844, and I find out that that's 62. It's a perfect square, so the square root goes away. Now I'm ready to split this into two problems, 4 plus 62 divided by 6, and 4 minus 62 divided by 6. That's what that plus or minus means. 4 plus 62 is 66. 66 divided by 6 is 11. 4 minus 62 is negative 58. Negative 58 divided by 6 becomes negative 9.7. I throw this one out because it's impossible to have a negative length of a side. Now, have I answered my question? This equation was about the width. I had w's in here. That means the width is equal to 11, and the units were inches, not inches squared. Length and width are just inches. Area is inches squared. I need the length. Remember, the length was 4 inches shorter than 3 times the width. So the length is 3 times the width minus 4. That becomes 33 minus 4, which becomes 29 inches. So let's go back through that. I drew my picture first. I labeled the sides. I set up an equation. I thought about whether it was linear or quadratic. In this case, it was quadratic. My two options were either factoring or quadratic formula. I could have factored, but the numbers were pretty large, so I decided it would be easier to use quadratic formula. So I substituted straight into my quadratic formula. I solved for the width, and I went back to my original box to solve for the length. Let's look at another example. We throw an object upward from the top of a 1,200-foot tall building. The height of the object, measured in feet, t seconds after we threw it, is given by this equation. So in this example, I don't have to think about what type of equation this is. They've given it to me. I just have to identify, is it quadratic or is it linear? In this case, it's quadratic because it has a t squared and a t. If it just had a t, then that would be linear. We can draw a picture. In this case, I've got a tall building. That building is 1,200 feet tall. And I'm throwing something from the top of that building up. And let's think about what's going to happen. It's going to go up a little ways, and then it's going to start to drop. It's making that nice parabola shape. It's got a vertex. It's going to go up and then back down, and then we've got the height here. So let's keep this picture in mind, and let's go to our next slide. It says, where is the object 3 seconds after we throw it? So remember, we've got this picture here that shows us we're throwing it up in the air and then it's going to come back down. What that's telling me in this case is the time in seconds is 3. It's giving me the time. And it's asking for the height. When that happens, I can just substitute straight into the equation. I replace the time with 3 seconds because I now know that it's 3 seconds. Make sure you use your order of operations. 3 squared is 9, and then negative 16 times 9 becomes negative 144. 16 times 3 is 48. I'm going to bring down the 1,200. Negative 144 plus 48 plus 1,200 is 1,104. Let's see, this was feet. So let's go back to our picture. Here's what this means. Some time is passing. We throw this object up in the air. At some point, it starts to go back down, and then that's about where it would be. It is shorter than, remember, it was 1,104 feet. So it's probably about right there after 3 seconds because it's been thrown up in the air and it's already on its way back down after 3 seconds have passed. So if you're given the time, you can just substitute right into the equation and solve. I didn't need to use the quadratic formula because I knew what t was equal to. Now, same question, same equation, same situation, same building. It says, when will the object reach its maximum height? That is a code word. You should write this in your notes. Maximum height is telling you that you need to find the vertex. The maximum or minimum is the vertex. So let's go back to our picture. That's our maximum height right there. That is the definition of the vertex. Remember that our formula for the axis of symmetry, which is the x value of the vertex, is negative b over 2a. Well, I didn't use an x in this equation. What did I use? I used t. That means this is actually going to be the time is equal to negative b over 2a. Remember, a is negative 16, b is 16, and c is 1200. So I'm going to substitute in. This is negative 16 divided by 2 times negative 16. Negative 16 divided by negative 32. That does not become 2, that becomes 0.5. So what that's telling me is it reaches its maximum height after half a second. In 0.5 seconds, it reaches its maximum height. Then it asks, how high will it be? Well, remember the last equation where it gave us the seconds? It told us that the time was 3 seconds. Now we just finished this up in the same way that we did that problem. It's giving us the time. So we're going to substitute that 0.5 in for t. So it becomes negative 16 times 0.5 squared plus 16 times 0.5 plus 1200. And that's going to give me the height. I square that 0.5 first. That gives me 0.25 times negative 16 gives me negative 4. 16 times 0.5 gives me 8. And then I'm still adding that 1200. Negative 4 plus 8 is 4. 1200 plus 4 is 1204. That means that I was only able to throw that thing about 4 feet in the air, so I wasn't able to throw it very high this time. So let's go back to our original picture and make sure we understand what's happening. Remember, I threw something starting from here. It went up to the vertex. That's what we're talking about. That's the point 0.5, comma, 1204. After 0.5 seconds, it went up to 1204 feet. That's the maximum height. Remember, maximum and minimum can be a code word for the vertex. When you see that maximum or minimum, you're often talking about finding the vertex. Let's try one more. When will the object reach the ground? So let's go back to our picture. We're talking about here. Well, what is the height when we reach the ground? If you were laying on the ground, your height would be 0 feet above the ground. So let's go back. Whenever something asks you when will it reach the ground or be at sea level, that's telling you the height is equal to 0. So we've got 0 equals negative 16t squared plus 16t plus 1200. I can't put 0 in for t. It's not asking me where will it be after 0 seconds. It's asking me when will the object reach the ground, which means the height is 0. You should now recognize this as us finding the zeros. What are the two ways that I know to find the zeros? You should have said either quadratic formula or factoring. I'm going to use quadratic formula again. You will find that I often use quadratic formula when the numbers are large and I don't want to try to take the time to factor. So A is negative 16, B is positive 16, and C is 1200. Notice I didn't put any variables on A, B, and C there. Quadratic formula is negative b plus or minus the square root of b squared plus negative 4ac over 2a. Negative b is negative 16 plus or minus the square root. B squared is 256, 16 times 16, plus negative 4 times a times c, all over 2 times a. I simplify what's inside the square root first, so that's negative 16 plus or minus the square root. Go ahead and simplify inside the square root now and see what you come up with. You should have said that it's 256 plus negative 4 times 16 times 1200 is 76,800 divided by negative 32. And so that should have become negative 16 plus or minus the square root of 256 plus 76,800. And you should have said that that's 77,056 there. Now we're going to use the square root of that number. And that gives me, I'm going to round to the nearest tenth, that's 277.5896. If I round to the nearest tenth, that's 277.6. So this becomes negative 16 plus or minus. Remember, I take off the square root at that point. I've used it to get the 277.6 divided by negative 32. Now I'm ready to divide this into two problems. Negative 16 plus 277.6 divided by negative 32, and negative 16 minus 277.6 divided by negative 32. Now I'm going to solve this. Negative 16 plus 277.6 is 261.6 divided by negative 32 gives me negative 8.2 if I round to the nearest tenth. I'm going to throw that out because I can't have negative 8.2 seconds. So let's hope the next one works out better for us. Negative 16 minus 277.6, and I hit enter. That's negative 293.6 divided by negative 32, and that gives me positive 9.2. That means that it's going to take 9.2 seconds to reach the ground. So let's go back to our picture. This is the point. Let's see, what did I say the answer was? Sorry, 9.2? Yeah. After 9.2 seconds, the height is 0 feet. It took 9.2 seconds for it to reach the ground. So let's get a little summary of our height problems. When someone asks you, where is the object some number of seconds after we throw it, you can just substitute in for t and solve. If someone asks you, when will the object reach its maximum or minimum height, that's code for finding the vertex. And when it says, when will the object hit the ground, that's telling you, or it could be, when will it reach sea level? Substitute 0 for h, and then find the zeros using factoring or quadratic formula. Pause the video and make sure you've written this summary in your notes now. So to solve an application problem, you can draw a picture, write an equation that could be either linear or quadratic, which is going to change how you solve it, and make sure you identify what you are being asked to solve for before choosing a strategy to solve. Thanks so much. Have a great day.